Hello? Really? Hi, John.
Oh, hey.
Okay. So, uh, now I almost finished all these problems.
Okay.
Let's start from number 4. Yesterday we finished the first 3, right?
Yes.
So now let's go to number 4. So can you read this problem first? Can you see my screen?
No, I can't see it.
Oh,
I can. Wait, did you screen share?
yeah. Now let me share my screen. Yes, let me share my screen. Now can you see it?
No,
Huh?
no, I can't see it. But I can look at it from my. I have it myself. You don't need to screen share.
See, I already. Let me see. Now can you see it?
No, what you have to do is click share screen at the top right.
Yes.
You see it, and then click the screen.
Yes.
Click
Yeah, I did that.
and then click share.
Yeah, I click share screen. I click this.
And then
This.
click the
Oh,
screen.
let me click this. Okay. Now can you see it?
No.
No. Can you see this page?
Wait, what? Are you in? I'm board one. Yeah. No, I can't see it.
Suppose I draw something.
Okay. Go all the way to the top right. I can see what you're writing, but
This is board 1, right? Then
yeah,
now it's page 1. Can you see it?
yeah, I can see your pen.
Yeah. Now can you see this page 2?
No, I don't see page two.
Oh, you did not see page 2? Oh, this is weird. Let me see. Entire window. Let me share my entire window. Now, what did you see now?
I don't. I just see the screen. Like you have to do this. Like, do you see my screen now? Do you see my screen?
Yes, I see your screen.
Is that what you're trying to do?
Yeah.
Yeah. All you have to do
See,
is
see, then you click the bottom. Say bottom page 2. You need to click the doc page 2.
right
Yes,
here.
yes.
Oh,
Okay. So
okay.
now you can see that, right?
Yeah, I can see.
Yeah. I hope you first read this problem number 4 first. Read this problem.
Okay, a block slides up a frictionless incline, slows to a stop, and slides back down.
Okay. So they ask you which of the following diagrams represents the direction. The direction. Okay. You need to pay attention to here. The direction and the change the color. The direction. First one direction and
Mm-hmm.
relative magnitude of the block's acceleration at the position indicated. So, can you draw the force analysis of this ball, this block?
Yes.
Can you draw on my screen?
Um, the direction of is like this. direction is like this, like that, like this. Right.
Yeah. See, the force analysis like this. First, you need to think this ball has what kind of force on it. Definitely it's gravity, right? Gravity in the vertical direction, that's m times g, right? Then say, but this ball move along this plane, move along this direction, right? So then we need to separate this gravity to the one. It's perpendicular to this moving direction. This way, that will be like this. Yeah, you have this direction, like this. Another direction that's this horizontal direction. That will be go this direction, right? Like this. Then they tell you, this also you have force, normal force. Normal force just perpendicular to the surface of this incline. This is normal force. So normal force.
Why does normal force go up?
Yeah, because the normal force tracks against this ball, right? Because this ball has gravity will act on the surface of this incline. So to get against that, based on Newton third law, this force should equals the aptitude will equals mg. Suppose this angle equals theta, that will be mg. This angle will also be theta. That will be mg times cosine theta. But then this go opposite of this force, this component. This one, because this ball keeps stay there, so these two forces should be exact. The aptitude is same, but the direction that's just opposite. Then another force, because you push this one and to the up with they did not tell you the, let's see, and slow, yeah, just like this. Then this ball also has another component of gravity that will be mg times sin theta. That will be this component, right? And this one will equals ma. So this is an acceleration of the ball. So then you get this acceleration will equals g times sin theta. This one, it's go to the down direction along this incline. It's this direction, right?
Yeah.
So then you can see here, now they ask you choose what's the direction of the acceleration on each point A, B, C, D, E, F, G, and also the amplitude. So they give you this arrow, like for this one, that means at anywhere at all these points, the acceleration direction it's just vertical and go down, and the amplitude for acceleration all same. So do you think this one's true? So which one you think it's true? So See, we already get that one. This one equals this. The acceleration equals g times sine theta, and the direction is along that surface of incline and go down. So you think which one is right?
I think 2 or 5. Wait.
First, from this formula, say g is a constant, right? This angle is also constant. So that means this a is a constant. Acceleration amplitude is a constant. Right? Because this one you can use 9.8 or you use 10, does not matter, but this one is constant. That angle of incline, this angle also is a constant. So then that means g times sine theta is also a constant, will not change at all. Then their direction is always along this surface of incline and go down. Also, that means the direction also keep not change. So then for this one, think this. Number 6.
Okay, what's number 4? I just want the answer and then I'll go back to see how it is.
Say number 4, it's wrong. Number 4 say this talk about you
no,
at.
What's the answer? What's the answer to number 4? That's what I'm saying.
What is the answer for number 4? That's 6.
It's which one?
This one. It's number 6.
That's wrong actually.
That's wrong?
Yeah.
Oh, then let me double check. So which of following diagram represents the direction and relative magnitude of block's acceleration at the position indicated? Now let's see. A, B, C, D, then E, F, G, direction of. Oh, let's see, relative. What I talk about here is absolute. So relative magnitude of the block's acceleration at the position. Okay, wait, that will be different. If relative, because when the block go up, the relative of gravity with travel direction, that's opposite. So that will be, you can consider that will be negative. When they go down, the direction is same. Then that will be. Now let's see.
Wait, what number did you originally think it was?
Original, I think that's 6. Now let's see. Now will be. Now let me think. Grab. Oh.
Actually, no, you're right. It is 6. It's 6.
It's 6.
Yeah. How'd you get 6? Sorry about
Yeah, I'm thinking. See, from the I calculate this acceleration. It's equals g times sine theta, right?
How'd you get that formula though? I don't know how you got sine, cosine, and this. How'd you get?
Yeah.
That?
See, this angle. Suppose this angle, the incline of this incline relative to horizontal, this angle equals theta, right? Then that means this angle also equals theta. Then this is a gravity, right? This is gravity. Then we try to analysis the force act on this ball, we need to separate this gravity to the two directions. One is along the direction of incline, another is perpendicular to the surface of incline. So then we use this angle, we can get the perpendicular component of gravity, that will be mg times cosine theta. Because in this right triangle,
Yeah.
this perpendicular, this side, that's mg times cosine theta. Right?
Okay.
This is a vertical direction. For the along the surface of decline direction, this one equals mg times sin theta. So sin theta, you know, this one, it's gravity component on the move on the traveling direction of this block. So now we are looking for the acceleration of this block or the ball. So then this force, this component, will have effect on the acceleration of this ball. So then this is a force. You know, force equals m times a, right? This is a Newton law. Force equals mass times acceleration. This is a force have action on this block. So then we use this one equals m times a. We can calculate acceleration of this ball. So then we can get a, say m cancel out. We get a equals g times sin theta. Then say here g, that's constant. That's a gravity constant. Then sin theta, this angle, that's fixed, because after you put this incline here, the angle is fixed. So even we don't know that angle, but that will be a constant. So that means a will be a constant. So then they ask you, what is this a's at amplitude and direction? The direction is always along the surface of incline, go down, and the amplitude always equals this. So then that's the reason why I choose 6. Okay, now let's go to number 5. Number 5 is similar with this. Say this is number 5. Now, can you read this number 5? Read this part.
Yeah, it says a block with an initial velocity VO slides up and back down a frictionless incline. Which best describes the acceleration of the block versus time? The initial position of the block is the origin. At equals 0 at t equals 0. Consider of the track to be the positive x direction.
Okay. So this problem, now they tell you to consider this block with initial velocity, that's v0, go up, then back down, fractionless incline. Which graph best describes the acceleration? Okay, still consider acceleration of the block versus time. You know, from the previous problem, this number 4, we already know the acceleration of this block, that will be same along the surface of incline, go down, right? And also keeps constant.
Okay.
So then you see what one will be the answer. They tell you go up, that will be positive, right? So consider up the track to be the positive x direction. So that means the direction of gravity, that will be, you know, the acceleration will be negative, because if you consider this direction, it's positive, then this direction will be negative. Our acceleration is along this direction and equals g times sin theta, right? So that means g is a constant, but also it's negative number. Then you can check which plot it's describe the g.
Number 4.
Number 4, see, this is a positive. See, above the x-axis, this a, that's a positive, right? So here that's 0. This one 0. If above the
Number 1.
let's check what number 1. Number 1, see, at time equals 0, at this part that's positive, but after this time then change to negative. But actually for our acceleration, they keep constant all the time, and also it's negative number. So which one you think?
It's constant all the time.
Constant all the time, but also it's a negative number.
So 3.
Yes, you're right. See, they constant all the time and less than 0.
How do we know it's constant?
Because we got a g, that formula equals g times sin theta. See, we already derived this one from the previous problem. So this acceleration equals g times sin theta. And this one's a negative because they tell us go up, this is the positive direction. Our accelerations go down, so that means this one's negative. But this g is constant. Sin theta is also constant. So then that means a is a constant.
Yeah, so it's 3.
Yeah, the correct answer is 3. Okay. Now let's go to click page 3.
That was number 5.
Yeah, then we'll go to number 5. We already finished number 5.
Yeah, let's go to 6.
Yeah, now go to number 6. This one is a little bit, let me see, this one is a little bit hard. Okay, so can you read this problem?
A ball of mass m is thrown toward the ground from a height 2h above Earth with a speed of gh to the half. A fractional force of constant magnitude 3/4 mg acts opposite to the direction of motion. How long does it take the ball to reach the ground?
Okay, so to solve math or physics problem, first you need to try to draw a diagram. See this one, suppose you have object, then you throw up the ground, go down, okay? Then say from here, suppose go here, this height that's equals 2h. So from here to here. Then they said with this one at the beginning with velocity equals gh square root, right? This power 1/2, that's square root. Then they said fractional force of constant magnitude that's equal this. Say this object, if they don't have the fractional force, this one still suffer a gravity force. So that's m, capital M times g, right? Then now they said has a fractional force. That will be the opposite of gravity force. This one will be fraction force. That will be 3/4 times mg, right? You know, the force act on this objective, you have two. One is gravity, another is fractional force. The both it's in the opposite direction. The gravity force that's go down, then the fractional force go up. So then from this force, we can get a formula that's m times g minus 3/4 times m times g. This one equals m times acceleration, right? This one it's net force on this object. Then you use Newton law. This one equals m times acceleration. By this way, we can get the acceleration of this object. Do you understand this? See, at any time, this object has two forces act on it. One is gravity, another is fractional force. The net force, that means sum of these two forces, that's equals mg minus 3/4 times mg. Then this one should equals ma. By this way, we can calculate the acceleration of this ball. So then you say this m cancels out, right? So then we got the a equals this g minus 3/4 of g. So you got the 1/4 of g. This is acceleration. Now they ask you the time when the ball reached the ground. Ask you the time. Here you need to use two formulas. One is the final velocity equals initial velocity plus acceleration times time, right? We try to find this time, but say here you don't know the final velocity, right? You also don't know the time. You try to looking for the time, but you need to find the final velocity. Otherwise, you cannot get the time. So that means we need another equation. Remember, we have another equation that's vf squared minus v initial 0 squared. This one equals 2 times a times distance. That's 2 times h. Now in these two equations, you have two variables. One is t, another is vf. Right? All other we know, like a, that's equals 1/4 of g. You can plug 1/4 of g, then a is gone. V0, they give us that's this one, g times h root 2. So in this two, h we already know. So in this equation, we have two variables, that's t and vf. Then that means we can solve this equation now to determine t. So now let's do it. To do that, first, let's say we can plug v0 plus a times t to replace this vf. Right? Now, let me do it. So, the vf, we can get a vf equals v0, that's equals g times h square root, then plus a, that's g over 4 times t, right? This vf equals this. Then you plug that one to here, right? So then you got this one will be gh square root plus g times t over 4. This one square minus v0, that's gh square root, this one square, then equals 2 times g over 4, this is a, then times 2h, right?
Yeah.
Now simplify this equation, right? Now let's simplify this side, that's 2 times 2, that's 4, they will cancel out with this 4. So the right side actually equals g times h. Then left side, this one need a square, need expanded. This one that's give you gh, right? So now let's expand this. That will be give you gh plus 2 times gh square root, then times gt over 2, then plus gt, this one square, t square over 16, minus gh, then equals gh. Right, now let me remove this stuff we don't want. Then we can see that clearly. You can see it now. Let's simplify this equation. Then you can see this one, that's gh. This one it's 2 times this one, 2. This one cancels out. You get the square root of gh times g times t. Then this one, that's g squared t squared over 16. Then equals both sides. Say actually this one cancels out with this. Then equals gh. Right? You know our variable now is t. We try to find t. We just need to solve this equation. This is a quadratic equation. Now let's continue simplify this. We can make this one because gh square root, this one equals v0, right? Then we can write this back. Later we'll plug in this one. Then we will make this one looks easier, because by this way there will be v0 times g times t, right? Then this term, that's g squared times t squared over 16. This one will equals v0 squared. Then both sides times 16. So this one will be 16. Well, then this one will be remove this. Then this one will be 16. Then we also both sides divided by g squared. Make this coefficient of quadratic term is 1. So then we got will be like t squared minus 16 v0 times t over this one over g. Then minus 16 v0 squared over g squared. This one equals 0. Now let's see. Then we need to solve this equation. Let's see. From the, let's see. Can we did something wrong? Now let's go from. Let me write this one more clearly. Okay. Then you can see this. Okay. So first, you already know we have two equations here. One it's Vf. This one equals V0 plus A times T. Okay, A times T. We already got A. This acceleration A equals G over 4. This acceleration A equals G over 4. Then we also have formula Vf square Vf square minus V0 square. This one equals 2 times A times this height 2h.
Yeah.
Right? So now let's simplify this one. We get this one equals first we still don't plug in that V0 expression first. Now let's still use V0. This one V0 plus G over 4 then times T. Okay, let's still use this. Then Vf this expression to here, we got V0 plus G over 4 times T, this one square minus V0 square, then this one equals 4 times A times H. You know, this one 4 times A times this H. A equals G over 4, so this one equals 4 times G over 4, then times H. So that means this one equals G times this H, right? So if you expand this, you got a V square plus G over 2 times T, 2 times V0 times V0, then plus G square over 16 T square, then minus V0 square. This V0 square cancels out with this, then this one equals GH, right?
Yeah, I'm ready.
Yeah, now let's plug in, V0. Actually, we can still keep V0, then make this one actually equals V0 square, right? So this equation we can simplify like this. G square over 16 times T square, then plus G over 2 times V0 times T, plus then minus V0 square. This one equals 0. This is the equation we are trying to solve. Okay?
Yeah.
To solve this one, you can use a quadratic formula. Quadratic formula, that's for ax squared plus bx plus c equals 0. This one x will equals negative b plus minus b squared minus 4ac, then square root divided by 2a. Do you know this formula?
Yeah, quadratic.
Yeah, quadratic formula. If you know this, that will be very easy. Okay, we already have this. So in this equation, you can know a actually equals g squared over 16, and b equals g over 2 times v0, and c equals negative v0 squared. Then you plug to this formula, then you get, now let's say negative b, that's negative g over 2 times v0 plus minus b squared, that will be g squared over 4 times v0, then minus minus times this minus, it will be plus. 4 times this, that will be g squared over 4 times v0 squared. Then this one square root divided by 2 times this a times g squared over 16. Okay, now we need to simplify this. See, this one plus minus. If you choose negative here, this one's negative, this one's negative. So gravity will be this time. You know, here we will try to find the time. Time cannot be negative, so that means you cannot choose negative here. You have to choose positive. To choose positive, then this solution will like this. Simplify this called discriminant under this quadratic, under this square root sign. Then we can simplify. You can say this one will equals, now let's write this one, that's g squared over 4. We can take this common factor out. They also take v0 out. That will be 1 plus v0. So then you can say, now let's see, this one, if we expanded this one, yeah, so this one will be times gh. Yes, now let's see. We can now plug in v0 equals square root of gh, right? So then we can plug here, that will be g squared over 4. Now let's see, we did some, let's see, that will be t squared. Let's say both sides, if both sides times 16, let's see, there will be t squared plus 8 times g, this will be g squared, and g times v0 times t, then minus v0 squared, this one will be 16. Yeah, this one will be 16. Why? Let's do this. Why this one? Let's see. For a, yeah, for a, then this for a g over g, a equals g over 4. Okay, then now let's see. This equation is vf equals v0 plus g over 4 times t. So this one, that's this. Then vf squared minus v0 squared, this one equals 2 times a, that's g over 4, then times 2h. So this one equals gh. This one actually equals v0 squared. So then we got this one, that's vh squared equals 2 times v0 squared. Then this one gives us 2 times gh. Now vh we can plug in here, that will be gh square root, then plus g over 4 times t, then you square this, then equals 2 times this gh. Now let's square this one, get gh plus g over 2, then square root of gh times g times t, then plus g squared over 16 times t squared equals this 2gh. So both sides minus this 2gh, we get this one will be g squared over 16 times t squared minus 2 this one, that's 2, this 2g over 4 times t. This one don't have a g anymore. This one will plus g over 2 times gh times t, then minus gh. This one equals 0. Okay? Then we solve this equation. We can get t equals negative g over 2 root gh. This is negative, this is b, okay? Then plus minus this one squared, that will be g squared over 4, then times gh square, this square, right? Because square then got gh. Then minus 4 times g squared over 16, then times gh. It will be positive. Then square root, that's 2 times g squared over 16. Now let's simplify this. You know, the one is negative g over 2, then square root of gh. This is the first part. Then plus the square of this one, that's g squared times gh over 4, minus, that will be plus 4 times this g squared, then times gh, that will be over 4. Yeah, so this one, say, they are exactly same. That's will be g power 3 times h divided by 4. This also divided by, this also divided by 4. Then add together will be divided by 2. This one square root divided by negative 2 of this, divided by 2 of this. This one is g squared over 8. Now let's simplify this one. We can get first one is a negative g over 2, then square root gh. Second one, we can write this one as take a g out, g, then inside that's gh. Then this one it's over root 2, so we can get this one. It's let's see, 4. That'll be, we can times 2 here. Then we can get a 1/2 here. Then this one will be times 2. Then divided by g squared over 8. Then simplify this. Both sides, let's say, we can take g over 2. This one plus this. That will be take gh out. Then this one will be root 2 minus 1. Then divided by g squared over 8. So that means times 8 over g squared. So this one cancels out with this. This one cancels out this, got a 4. So the final answer is 4 times root 2 minus 1, then times g, then times g times let's say times gh 4 times root 2 minus 1, then times h over g. Let's say this one, let's see, okay, this one, g squared, yeah, g squared. So this one cancels out. This one divided by g, this one divided by g. So the final answer equals 4 times parentheses root 2 minus 1, then times square root of h over g. So the correct answer is 1. Can you check if correct answer is 1?
Yeah.
Yeah. So I told you this one is kind of hard. You use a lot of math. You need to solve a very difficult system of equation with 2 variables. Now, first, let me explain for you. Do you understand this?
A little bit. I understand the formulas used.
See, the final speed equals initial speed plus acceleration times time. So we already found the acceleration of this ball, that's g over 4. Because this ball has 2 force act on it. One is gravity, another is fractional force. That's 3 force m times g on the up direction, mg on the down direction. So then we get mg minus 3 fourths mg, then this one equals ma. So then we can solve get a equals g over 4.
Yeah.
Then this is the first equation. You need to understand this. Then second equation, that's final velocity square minus initial velocity square equals 2 times acceleration, then times the distance. Then by combine these two together, cancel out Vf, then get the equation related to t. That's equals g squared. That's this.
Okay.
That's this equation. G squared over 16 times t squared plus g over 2 times square root of gh times t minus gh equals 0. Then you use a quadratic formula, that's this, to solve this quadratic equation. Then you will get the correct answer is A. It's the first one, 1. Now, did you get it?
Yeah, I'm afraid we only have 5 minutes. So could you just send me the work through messages? Please?
Yes. Then say
with the written work.
You mean that I can give you all these answers now?
Okay, give it to me. What's number 7?
Let's see, number 7. No, give me a second. Oh my god. This is number 7. Number 7, that's 1.
Number 1.
Yeah, answer is 1. Can you check if that's correct?
Yes, that's correct. What's number 8?
Okay, now let's go to number 8. That's the next page, right?
Yes, I believe so.
Okay. Number 8, that's the correct answer is let's see, number 4.
Number 4.
Is that correct?
Yeah, that's correct.
Okay.
9.
Now number 9. Number 9, actually I did not finish this one yet. So then I got no more force, but I did not finish the two the last solution, but now I can, let's see, probably I can.
You just sending me the answer through message.
Yeah, I will tell you this method after I finish this one. I have not got this final answer yet. I got the expression, but my expression is not the same yet with any of them. I need to do more extra work. Okay. Then now let's go to number 10. Number 10, that's 1. Is that correct?
Checking right now.
Yes.
Yeah, that's correct.
Yeah, that's correct. Then now let's see number 11. Number 11. Where's my answer? Number 11. Number 11, it's number 4. It's 4.
Yeah, it's 4.
Okay, number 12. Let's see, number 12. That's 5. That's 5. Is that correct?
No.
Yes. This is a very easy. That's Newton rule. Number 13. That's 2. Is that correct?
Yeah.
Okay.
Yes, that's correct.
Now number 14. It's 4. Number 14 is 4.
Okay.
Is that correct?
One moment. Yes, that's 4.
Okay. Number 15, that's 1. Is that correct?
One moment, it's still calculating.
Okay.
No, it's not. It's not 1.
Ah, it's not 1.
No.
Now let's see. That would be, if that's not, you can try 7. You can check if 7 is correct.
For 15?
For 15.
No, it's not.
Ah? I get, this one should be right. Now let's see. Okay, let's check 16 first. 16, that's 3.
3?
Wait. Now let me see this one. Wait. I got this one. Oh, wait. This one actually not finished yet. Now let's see. I will set these 3 problems answer to you later. Okay? How about that?
But could you send me all the work you did?
Yeah.
For all of the questions.
You mean, or let me write all the details?
Yeah.
That's a lot of work.
Okay, no problem. It's okay,
man. I will set it. I will have this. Record. I can.
Okay.
I can set this record. Then you can.
Yeah, I have a recorder too. Yeah, I get it.
Okay, sure. That's write down. That's a lot of work. So I can set you the answers for the left problems. Okay.
Okay. Thank you so much.
Yeah. So we can stop here. Bye.